Welcome all. Today the lesson is on computer and data networks. Now we are going to learn about the Dijkstra's algorithm. What is actually Dijkstra's algorithm? In the data networks, the term routing is specially used. Routing refers to the finding the best route for data packets to flow. In order to fulfill that task, there are some kind of algorithms introduced for that. This is about the Dijkstra's algorithm. Let's see how it can be done. As you see, here the example is given. Here there are some points U, X, V, W, Y, Z. So here the distance between 2 points or the cost can be given as here as 5 and here 3. Likewise there are the numbers represented by that, the cost or the distance of that 2 nodes. So we need to get the best route for the nodes to be data transmitted. In such a problem like this way, we have to solve the shortest path for the U terminal to Z terminal. That means in each node we have to give the path where that data packets to be go through. So let's go to the question. Here this is this we have to draw the table like this way, and first column is step N, dV, dW, dx, dy, dz. Here we represent the distance like how it could be. Let's see how to fill this table. We consider our main node is U. From U we need to find the shortest path to the each node. So this is the step 0. We consider this step as 0, and because it's not moved somewhere else, just taking the place where itself. So we take U. From U we have to write the distance to these nodes. So here you see the V. To V it takes 7. So how we write this data into this table is we write as 7 and the place where it comes from. Likewise here 7, U. In W case it comes from, we are considered from the U, so here U, from U to W 3, so 3, U. Then we consider X. For X it takes 5, so 5, U. For Y here, there is no direct connection to U. It has go through these paths, no direct connection. So in these cases we write the infinity mark over in the table. To the Z also there is no connection to this U, so here is also infinity mark. After filling this row, we need to consider the lowest value from this data. Here you get 3 as the lowest value. So we need to circle that value and we need to go to the W value. So we write as first step UW. from that place we are going to see the distance from the W itself. So we don't put data to this column again. So we see how the data is going to each node. So from W, the W cost is 3, the W distance is 3. Here you see it's 3. So we have to add that value to the relevant paths. So we are consider V. Now we come to V from W. Here we come to W and V because it's UW, not U, it's coming from UW. UW it's go to V in another 3, adding of 3 value. So here it takes 3 value, that 3 and this 3, 6. So the value come to this cell is 6. We have to, before putting the value, we have to see the previous value in that cell. So here it takes 7. 6 is smaller, so it less cost. We need to find the shortest path, shortest distance. So we write 6. Here we write the letter W because we coming from the W now. So we write 6W. Likewise, we coming from W, we go to X. Here you see the distance is 3. Here 3 plus 4. W to X, W to here W to X, 3, 4. It comes as 7W. As I told earlier, we need to consider about the previous cell. Here it's 5U. It is somewhat small value than the type answer we get into this cell. So we never write the value of that 7W. We repeat the previous answer because what the answer we get from the this column is greater than the previous one. So we repeat the previous answer. So we come to the Y. Can we reach Y from the W? Yes. So we calculate the distance. Here the distance is 3. Here 3. 3 plus 8. 3 plus 8 is 11. 11 it comes from W. Can we reach W to Z? No. Therefore it remains infinity mark. Now we have to go through this row and collect the least amount of value. So you see here 5. So go through this column, we see that it's X. So we write as UWX. That is the second step. UWX. But X is the shortest path is this 5, not this 7. So we write as UWX, but the shortest path we identified as 5. So we wrote that value in here. Now, once I told that this column is, we are not going to put the values to this column. Likewise, we are not going to put the values to this column also. So we only need to consider these 3 columns. So let's see the distance from X to V. So X to V, there is no direct connection. X to V. Therefore, we have to put infinity mark or write the previous answer. So we write 6W as there is a previous answer. These columns are neglected and we go to the Y. Is there is connection to the Y from X? Yes, there is a connection. So let's calculate the distance. Y, the cost to X is 5. 5 plus xy 7. 5 plus 7 12. 12x, but 12x is greater than the previous value, so we never write that value and we repeat the previous value 11w. And let's see whether we have connection to z. xz, there is a direct connection. Here you go, we add the value here to this value and write as 14 here x. Now all the infinity marks were gone. As I said previous, now we need to consider again the lowest value. Here 6, 11, 14. So this is the lowest value. Here v. So we write as u, w, x, v. And it's our third step. So from v, we need to consider the other elements. But these two columns, we are not going to put the values again. So we need to consider about these two only. So from v, the cost of v is 6. So we need to add the value of 6 to this distance vy. So cost is 6 and 6 plus vy 4, 6 plus 4 10. So it is 10v. To the distance to the y is 10v. So we are going to write here, and before write we have to consider the previous value. It's lower than the previous value, so we are going to write that value 10v. v is taken from here, that we are coming from v. Then let's consider about the z. There is no direct connection, therefore we have to write the infinity mark or the previous value. There is a previous value as 14x, we write the same as 14x. Now the two answers are remaining. From that one, here is the lowest value, that is we are taking from the y. u, w, x, v, y. That is our fourth step. So we only these columns are neglected, so we only considered about the z column. So the distance from y to z is 2. The shortest path to y is 10v. 10 plus 2 is equal to 12. The 12, it's 12y, and 12y is lower than this value, so we are going to write that value in the table 12y. From this row there is no any other values, so here it's circled, and we go to the path. We write the path as u, w, x, v, y, z. Here z is coming to here. Is there anyone to be filled? No. Now we are completing the table. So now we are going to show how the shortest path is taken. Before that, let's draw the nodes here again. U, x, w, v, y, z. From this table, we have to consider the which column has gone far. So this column is gone far, so we go to this z value and we combine this z value with this value, so zy. From this value we go to the head of the column. Here y is directed to v. Now we go to the v. V is directed to here v is directed to w. Here v is directed to w. Then we go to the w. W is directed to u. directly. So here u. We gone through this value, this value, this value, this value. Which is remaining? This x. X is coming from u. So we draw likewise this way. So the shortest path for the nodes to be connected from u is this way. If the x wanted to connect, here direct connection, w direct connection. V, it's more beneficial coming through the w. Likewise, you see the pattern. So this is the answer for the Dijkstra's algorithm in this question.